Specific heat capacity. Now, specific heat capacity, before you understand the concept, we'll be conducting or observing a small experiment. Take three spheres of iron, copper, and lead of the equal mass, means three small balls of the equal mass. Put all of them in boiling water for the same time. Take the three spheres out of the water. All the spheres will be at a temperature of 100 degrees Celsius. Now immediately put them in a block of or slab of wax. Note down the depth at each, or that the each of the sphere goes inside the wax. Means we take three substance, that is iron, copper and lead ball, put it in boiling water for some time and then put it in wax slab and see how much depth are they traveling. Now the sphere which absorbs more heat from the water will give more heat to the wax. More wax will thus melt and the sphere will go deeper in the wax. It can be observed that iron sphere goes deepest in the wax, lead sphere goes the least, and whereas copper sphere goes somewhere in between. This shows that for equal rise in temperature, the three spheres are absorbed different amount of heat. This means that there is a property which determines the amount of heat absorbed by a sphere is different for these three spheres. This property is called as the specific heat capacity. In other words, every object has a different capacity to absorb heat. For example, if I am taking an iron ball. Now iron ball, if I am putting it in boiling water, it will be absorbing heat. But suppose I am putting a plastic ball, what will happen? It will melt. So obviously, because the substance is different, their capacity to absorb heat will also be different. This quantity is called as specific heat capacity. And this specific heat capacity is defined as the amount of heat energy required to raise the temperature of a unit mass of an object by 1 degree Celsius is called the specific heat of the object. It is denoted by small letter C and its unit is joule per degree Celsius in case of the SI system, and in the CGS system its unit is calorie per gram degree Celsius. They've given you a chart over here which shows who has the highest specific heat and who has the lowest specific heat. If you see, water has a specific heat of 1. And if you remember in the lower classes, especially in the 7th standard science, when we had learnt about the chapter heat, there were certain points about water we had learnt. And the one important thing was that we use water in the cars and etc. radiator to cool down. Why? Because water has the highest specific capacity and because of which it can withdraw or the take out the heat from the radiator. Also when we have fever and etc., we take that what we put, we may take a small cloth and we put it in water and put on our forehead. That is basically to absorb the heat. Same way when we play and our body becomes very hot, we splash water on our face. Why? Because water has the capacity to absorb heat from the surrounding and immediately our body cools down. The specific heat can be measured by, the heat absorbed can be measured by a formula m into c into delta T. Now whereas m is the mass of the object, c is the specific heat, and the temperature of the or difference in the temperature is given by delta T, where delta is the small triangle. So that small triangle is read as delta, and the delta means a difference in temperature. It's actually a Greek alphabet, and T is the temperature. Heat exchange. If heat is exchanged between a hot and cold object, the temperature of the cold object goes on increasing due to gain of energy, and the temperature of the hot object goes on decreasing due to loss of energy. The change in temperature continues till the temperature of both the object attains the same value. In this process, the cold object gains heat energy and the hot object loses heat energy. If the system of both the object is isolated from the environment by keeping it inside a box, heat resistant box, meaning that the energy exchange takes place only between the two objects, then no energy can flow from inside the box or comes into the box. So from this we get the principle of heat exchange. What does this principle tells you? This tells you that in an isolated system, the heat energy lost by hot object equals heat energy gained by the cold object. That means heat energy lost by the hot object is equal to heat energy gained by the cold object. Now this can happen only in an isolated system or in a system where there is no system of heat being lost to the atmosphere or heat coming in from the atmosphere. This can be explained inside a calorimeter. Now the specific heat of an object can be measured using this particular method. For this a calorimeter is used. We have learnt about calorimeter in the lower classes also. You have learnt about calorimeter, and if a hot solid object is put in the water in a calorimeter, heat exchange between the hot object and the water and the calorimeter starts. This continues till the temperature of the solid object, water and the calorimeter becomes equal. Therefore, heat lost by the solid object is equal to heat gained by the water in the calorimeter and heat gained by the calorimeter. So if you remember, I will just revise little. Calorimeter is a wooden box inside which you have an insulated substance. Inside that you have a metal container. So here and inside that you have a stirrer and you cover it on. So what we are telling is, suppose we take in that calorimeter, we take a hot solid object and we put it inside the calorimeter water. So for example, initially what you do is you measure the temperature of the water. Then you take the solid ball and object, metal object, heat it up and put it in the water. So since it is heated, who will lose heat? Heat will be lost by the solid object. Who will gain heat? Heat will be gained by the water as well as the calorimeter. So the heat lost by the solid object will be equal to heat gained by the water in the calorimeter plus the heat gained by the calorimeter. So if Q is the heat lost by the solid object, so it will be Q is equal to M into C into delta T. And if Q1 is the heat gained by the water and Q2 is the heat gained by the calorimeter, so we get a relationship, that is heat gained by the hot object is equal to heat gained by the calorimeter plus heat gained by the water is equal to Q is equal to Q2 plus Q1. Using this particular equation, we can find out the specific heat of water and calorimeter known, and then the specific heat of the solid can be calculated. We'll be seeing that when we are solving the numericals. So to continue, that in the previous one we saw that the maximum temperature was 100, and so since it is heat lost, it became 100 minus T. Whereas in Q1 the temperature is less, that is 20, so it becomes T minus 20. Now for Q2, that is the heat gained by the calorimeter, mass is 50 into 0.1 into T minus 20. Now solve the equation. Q is equal to Q1 plus Q2. Write down the given, substitute the values and then solve, and you get the value as T as 23.8 degrees Celsius. So therefore the maximum temperature of the water will be 23.8 degrees Celsius. Third example, if 80 grams of steam of temperature 97 degrees Celsius is released on an ice slab of temperature 0 degrees Celsius, how much ice will melt? How much energy will be transferred to the ice when the steam will be transformed to water? So given part is latent heat of melting of ice. This will be given to you in the exam. 80 kilocalorie, latent heat of vaporization of water 540 calorie per gram, mass of steam 80 gram, temperature of steam 97, temperature of ice 0 degree. So heat released during the conversion of steam into water is equal to mass into latent heat of vaporization, that is 80 into 540. Heat released during the conversion of water into water at 97 degree into water at 0 degree, that is again M into C into T, 80 into 97 minus 0 into 1, that is 80 into 97. Therefore, the total heat gained by the ice will be equal to the heat lost during conversion of steam into water as well as from water into, that is the latent heat. So the equation becomes 80 Combining 1 and 2 equation, 80, 540 plus 97, which is equal to 50960 calorie. So the heat for mass of ice that is given to us. So what will be the, so if some mass of the ice will melt due to this heat gained by the ice. So it is mass into again latent heat of melting, which is again equal to m into 80 equals to 50960. So what will be the mass of the ice? 637. So that is the amount of ice that will melt, and this 50960 will be the calorie that will be given to the ice.